Hello! Today I will talk about recursion. What is recursion? Well, if you think of yourself as a computer scientist and you don't know what recursion is, shame on you. Basically, it means self-reference, that using recursion for problem solving means that you are referencing to yourself several times in order to get the answer. Each recursive call should conduct to a problem of a smaller size, so the problem should get smaller as you continue on with it. The chain of self-reference is eventually terminated by a base case which you define yourself. A general form of using recursion is that you have to create a method or a function in code, in programming, and it will generally have an if statement that checks for a base case or a trivial case, in which case it will do something and then exit or stop the recursion. Otherwise, else, it will do something and then call upon itself again. It will call upon the function name that this is within already. For example, suppose you want to create a simple factorial program. To remind you, factorial of 5 would mean, for example, 5 times 4 times 3 times 2 times 1, which in this case would be 120. That you would multiply the number times every number between itself and 1. Well, to use recursion, we would first have to define a base case for us to exit. The base case will be the smallest value that it can be, which in this case is 1. Because if you have a factorial of 1, you would return 1. Else, if you have another number, it will eventually go down to 1, in which case you should stop at 1. So we'll start with that. We'll have an if statement that says if input is equal to 1, then return 1. General case. Well, what if the number is not 1? What do we do with that? Well, it would be calculated by the given factorial number and by multiplying that with the rest of the factorial. For example, if you input 5, and we want to find the factorial of 5, we would say 5 times the rest. So we would say 5 times the rest would say 4 times the rest, 3 would say 3 times the rest, and so on. And as you can see, the question is literally getting smaller as we continue. For example, user input the factorial of 5. You would sub in the variable n as 5 to make this more general, so we get a better understanding for other possible inputs. We could say n times the rest of the factorial, and the rest will be n times the rest of the factorial, and so on, where n will be the input into that method at that time. Okay, now that we are putting both the base case and the general case together, we would get this method, which is really simple. Okay, let's trace this program. Let's say that you actually did input 5 as the input, and we want to use this program to find the factorial of 5. Okay, so we would check to see if 5 is equal to 1. No, it's not. So we would say else, we return 5 times the factorial of 5 minus 1. So we're going to say 5 times, well, what is factorial 5 minus 1? Well, we have to keep checking for that. So we would say now, we would call upon factorial with a number 4. And we repeat ourselves again for 3, and then 2, and then finally 1. If your input is 1. Is 1 equal to 1? Yes. So you return 1, and that's it. That's all you call. So now we have 1 times, 2 times, 3 times 4 times 5. And that's how it goes. So that was a simple recursion program. Recall, for example, the user inputted a number, and the number 5 became 5 times the rest, which became 4 times the rest, 3 times the rest, and so on. Okay, so good job. That's one example of how you can use recursion to solve computer programming. This helps a lot to make your code overall a lot shorter in length. Sometimes it can make the code run a little faster, not always. In fact, most of the time this tends to make the code run slower, but it's usually not by too much. And it's an interesting way to do it. There's a lot of different questions out there that can be solved using recursion a lot easier than without. Okay, thank you for watching. Have a good day.